We are on the section 4.5, residuals, page 42. Okay, one more thing about lines we are going to talk about is the residuals. So, take a look on your page 42 on the top. What do they mean? It's a quantity remaining after other things has been subtracted or allowed for. Okay? In the linear regression part of statistics, we are often asked to find the residuals. Given a data point and the regression line, the residual is defined by the vertical difference between the observed value of y and the compute value of y hat based on the equation of the regression line. So let's see, what are we talking about? Okay, it's something called residual, and it's y minus y hat. Okay, so it has a special meaning. So y is what? Observed value. So we are talking about y is the observed value. Then y hat is what? What do they say? Y hat is based on the equation, compute value. Okay? So, compute. Okay, from the equation, from the formula. All right. So, you learn one more symbol called y hat. When we use y hat, means what? From the equation, you calculate the value, okay? Calculate. Then y is observed value. Then we are going to find that the difference between them is what? Subtract the value, quantity, right? Remainder after you do the subtraction, okay? And let's see some examples, so you might have some idea. Okay, it says a study was conducted asking female college students how tall they are and how tall their mother is, and the results are shown in the table. So 2, 3, 4, 8 people they asked. Okay, so they find out, and that's mother's height. Okay, and that's daughter's height. So they actually ask people about it. So if they ask people about it, that means what? All these are what? Observed value. Because, right? Means what? Actual value. Actual number, what they are. They ask people, then that's what it is, right? And it says the regression line is what? It's given this way. Y hat, okay? Y hat is this way. 30.28 plus 0.52x. Okay, the line is look like this. Probably x0, that would be that, and go like this. The more x you have, the more y you have. Right? That's your x, that's y hat. Okay, so what does this line mean? What is your x? What is your y? You need to decide. Okay? What it says? So which one is x? Which one is y? Y is daughter's height. Y is mother's height. Okay? It says what? Let's take a look. Which one is x? Which one is y? Okay. A study was conducted asking female college students how tall they are and how tall their mother is. Okay, so the higher the mother is, the the taller the mother is, the taller the daughter is. Looks that way, right? According to this equation. Or the taller the mother is, the taller the daughter is. Or the taller the daughter is, the taller the mother is. Which one is which? Okay, let's look at the question again. A study was conducted asking female college students how tall they are and how tall their mother is. Can I tell? I cannot really tell. Man. Okay. Usually, we put the top one. Usually it's your X. Usually it's your Y. Okay? Because the daughter's height is from the mother, usually given. Right? Okay? It's not clear on this question. Other questions may be, clearer than this. Okay, this one they didn't tell you, but we just assume. Okay, X is mother's height, then daughter's height is Y. Okay? And it asks you find the residual for the mother who is 59 inches tall. Okay, so when X is 59, it wants you to find the residual. So we need to find according to the equation, right? When X is 59, what's your Y hat? What's your Y hat? Y hat would be per equation, per formula, right? So let's see. Y hat would be, according to the equation, 30.29 plus 0.52 times 59, you end up what? 61.06 from the equation, right? Y hat is the prediction according to the line. Expect if the mother is 59 inches, we expect the daughter around 61 inches. But when we did the observation, then at X equals 59, what is Y? Y is 61 from the chart. Right? This is observed value. This is a calculated value according to the expectation predicted line, right? So between the expectation and actual, what's the difference? That would be the difference is your residual. Is the difference, right? That would be according to the formula we wanted to do. Y minus Y hat would be 61 minus 61.6. That would be what? Negative 0.6. Okay? So then we see Y is according to the formula you predict. Y is actual. So what kind of situation we are in? So what does it tell us, right? Then we say since I just write it out so you can see. Since the residual is very close to 0. What does that mean? That means that the line, that means that the regression line is pretty good on predicting, right? What do you think? Was what? Accurate enough. For predicting, right? So accurate enough predictor of the daughter's height. Is that so? What do you think? Right? So if the actual value is close to predicted value, that means your regression line is good enough. So we use a residual to kind of evaluate our formula equation we use to see if we want to use the formula to predict the future for somebody's height. Then we might be able to use this and feel comfortable to predict. Okay? So we use the residuals to decide such a thing. Okay, next one, look at next one. An online retailer wanted to see how much bang for the buck was obtained from online advertising. So we collect the data, okay? The retailer experimented with different weekly advertising budget, and logged the number of visitors who came to the retailer's online site. The regression line for this shown below. So they collect the data, see how much advertising budget they spend, then how many visitors it has. So according to this, the more money you spend on the budget for the advertising, then you have more visitors because it's more visit, right? People can see. So if we look at this, what do we have? So at x equals 600. Okay, we look at this one, 600. Okay, one is observed value, scatter plot. The blue one is actual value, right? Then the line is we made up to satisfy the condition so we can do prediction. So at the 600, so you have what? One is actual value, one is what? Predicted value. Y hat is what? Predict value from the regression line. So you need to differentiate what is y and y hat, right? So at x is 600, then y is what? 600. Okay, and 600. I'm just trying to see if I did a good graph here. Okay, so x is 600, y is what? Actual, right? Y is observed. So y is observed, that should be here, 800. Right? Then y hat, 600. Y hat should be this guy. Right? Then you look at your graph, y hat is what? 700. Okay? So this is observed. Okay? Then y hat is on the line is what? Predicted from the line. Right? Okay, then what's the residual at that point? Because it says find the residual for the week when the retailer spending $600 budget, right? What's the difference? So your residual would be y minus y hat, right? observed minus predicted. Observed minus predict. So it's 800 minus 700. It's 100. 100 for what? For Y, it's a visitor. So when you spend $600 budget for the advertising, you have what? 100 visitor difference as you predicted and actual happened at the time, okay, according to the data we collected. Okay, so what we are saying on this graph, what does it tell you? So when $600 was spent, right, was budget on the advertising, right? What happened to the situation? The retailer expected to have how many visitors? Expected to have, according to the line, right? Expect to have 700 visitors online, right? Because you spend money, you predict, according to a certain way you think. Then, but the actual may not be the same, right? So that's the scatter plot, we call it, those blue one, right? So what happened? But the actual visitors was how many? You actually have 800, okay? So there's a difference. There is a difference of how many people? 100 visitors. So the predictions and actual may differ, okay? Then we call them residuals. Okay, so it happens when you do the prediction, when you do the stats, and when you use the observed data, then you will cause the residuals. So you identify those residuals. Sometimes we use the residuals to decide if the formula with the prediction line, the formula for the prediction line, is good enough or not, okay? Then sometimes you have the line, then you find out what's actual difference from your line, from the regression line you expected, okay? That's how we use the residuals. So that would be your section 4.5.